Ladies and gentlemen, welcome to the seventh edition of the TSDSI Tech Deep Dive 2024 conference. We are happy to have you here from 16 to 19 July 2024. We have six online technical sessions that will dive deep into the world of global standardization activities and leading technology trends. Then, on the 19th, we'll come together in New Delhi for a special hybrid session. Our theme for this year is realizing the 6G vision, societal needs, usage scenarios, and technologies. We'll be discussing important topics like usage scenarios, emerging technology trends, ubiquitous intelligence, AI enabled future networks, security and privacy, spectrum aspects for 5G advanced and 6G, and rural broadband technology landscape. Our special session will focus on realizing the 6G vision, societal needs. Key findings from the conference technical sessions on usage scenarios and technologies will be used as a reference point for discussions in this session. Throughout the conference, we'll showcase the work happening in TSDSI and around the world. We'll talk about research, industry trends, and new ideas that could become standards in the future. We are also conducting a dedicated session on TSDSI overview on the 19th to familiarize the audiences with our technical activities and processes. Please do join us for the TSDSI Awards ceremony on the 19th in New Delhi or online to celebrate the TSDSI experts who contributed to standards in the financial year 23-24. This conference isn't just about listening, it's about sharing ideas and finding ways to work together. We hope you have a fantastic time, make new connections, and leave with ideas to make the world a better place with 6G technology. Thank you for being a part of TTDD 2024. Let's get started. I now invite my colleague Akash Malik to take the proceeding forwards. Over to you, Akash.
Thank you, Shefali ma'am, and good afternoon, everyone. I am delighted to welcome you all to the first session of the TTDD 2024 conference. The session is titled User Scenarios, and we are all excited to have you join us online. Firstly, I would like to extend a heartfelt thank you to our session silver sponsor, Tejas Network, for their generous support in making this session possible. Now, before we proceed, let me quickly go over some housekeeping guidelines to ensure a smooth and engaging session. All attendees, except the session speakers, will be kept on mute throughout the session by default. Please type questions for the speakers in the Q&A tab. The questions to the speakers posted in the chat box will not be entertained. It is recommended to type all questions for the respective panel discussions within the first 40 minutes to give moderators sufficient time to address them. You may interact with fellow attendees live using the chat tab during the session. If you want to enlarge your presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for HD video. You may switch to low definition in case you are facing bandwidth problems. This webinar is being recorded and will be posted to the TSDSI website within the next few days. Now, it's my pleasure to introduce the session convener, Mr. Vijay Madan, who is associated with TSDSI as advisor and mentor with special focus on standardization in services and solutions relating to evolving technologies, applications, vertical sectors use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems, and many more. You and over to you, sir.
Thank you, Akash, for introducing me. I welcome all the distinguished chairs, speakers, and the audience to this workshop. And ours is our first session. So I'll now introduce our distinguished chairs, please. Akash, can you? Yeah, we have Jishnu from Tejas Networks and Paventham from ERNET India. Can you show the biodata of those two? Actually, he is an expert architect principal architect of technology in CTO's office in Tejas Networks, and he has more than 19 years of experience in the field of telecom. Over and above, he is participating in so many conferences and other things. He is actively participating in 3PP, ITUR, and others, and he is well-known expert in that domain. So I am leaving the rest part in interest of time. Kindly go to the next. Session co-chair also is Pavantham. He's from Dr. Pavantham is director R&D with EarNet India. Everybody understands EarNet. Is an autonomous society under Ministry of Electronics and IT. At EarNet, he has handled R&D projects in various domains, including Internet of Things, EU-funded MyFire Future Internet, educational cloud, visible light communication, tactile internet, and QKD network security. Thank you very much, the distinguished chairs. I hand over now to the chairs to go through the proceedings of today, 2 hours session, and over to you, and welcome all.
Thank you, Madan sir. All of you, it's I think the first panel discussion, and I welcome all the esteemed panelists for the 7th TTD event. We will do a tech deep dive starting with the usage scenario, and let me introduce all the panelists. So can you just wait? Yeah. So our panel includes Ashok Kumar sir, Ravi Lakhotia, Satish Jamadagni, and Saurabh Mittal. So Ashok Kumar sir, right now is an officer of ITS and works in Department of Telecom. He joined in 1995. Previously, he was the DDG Wireless Access at NTI PRIT, which does research in telecom. He holds the position of Vice Chair of Study Group 16 of ITUT. Next one. Ravi Lakhotia is from Vodafone Idea. He has 25 years of experience in telecom industry. He has worked with both telecom OEMs and service provider. He's currently serving as a strategy radio planning team and focuses on 5G planning. Next one. We have Satish, who is Senior Vice President and Head of Global Standards from Reliance Jio. He has 23 years of experience in telecom domain, and he's served as the Vice Chair of TSDSI, and he has close to around 200 granted patents in wireless and network domain. Next one. Saurabh Mittal is from Bharti Airtel. He leads the standards and technology ecosystem in Airtel. He has been the key instrumental person for running the Open RAN program. And he has 27 years experience and had done multiple initiatives all the way from 2G to 5G. So maybe I request all the panelists to switch on their videos. So this session, what we are planning to do is that there would be 3 subsections, which would be for questions from me. After that, we will take Q&A from the audience. So please, as mentioned by Akash, please type in the question in the Q&A box, and we will take that up at the end of the session, which would be for around 20 minutes. So can we start we have all the 4 panelists. Akash?
So yes, we can start. Mr. Satish Jamadagni is on the way. I mean, he's
Okay, so I will we'll wait. We'll ask the questions and let Satish join in. So Saurabh, let me start with you. So I think India has seen one of the fastest deployment of 5G anywhere in the world. So can you sort of explain what is the present status of 5G usage scenario, all the three of them, EMBB, MMTC, both in private and public network. And what has been your main learning from that?
Sure. Thank you, Jishnu, and thanks to TSDSI for giving this opportunity. I think it's a wonderful time to actually reflect on how we have done in 5G, what's learning from that, and then how do we actually build on top of it. Just to check if my audio is clear.
Yeah, it's very clear. Yeah, please go ahead.
Yeah, thank you. So, I mean, as you said, that the ecosystem in India, whether it is TSP, the equipment providers, even including government and all the other enablers, I would say that they have done exceptionally well in last 18 to 20 months on the rollout. So, if you look at in 2022, August of 2022, the spectrum auction happened, and then the spectrum was actually given out very quickly after the auction. And on 2nd of October, Honorable Prime Minister inaugurated launch of the 5G services from the IMC grounds in Delhi. So if from that time till now, I would say across the length and breadth of India, now 5G coverage is available. Now it is not just unlike many other developed markets where the 5G is available only in the urban centers, but in India this has actually gone to the villages as well. I mean, of course, it's not that the 100% territory is covered, but in terms of what essentially the pace of rollout has been there is very, very exceptional. And this is something which is reflected in the other uh, global benchmarks which are essentially done. So if I were to give a small stats, right, if you look at the UCLA's speed test index, this is the global speed test index, India's ranking essentially jumped up dramatically following the launch of 5G period. So in August 2022, India's ranking was somewhere about 117. It jumped to 74 places, went to 47, and then it has actually jumped further to 15 places in the the first quarter of this year. So, and it has actually coincided pretty much with the launch of the 5G in India, both by Airtel and Jio. And this other part is that India, if you look at now and measure the mobile broadband download speeds and also the fixed line broadband speed, then the mobile broadband speed is now kind of higher than slightly or same level as the fixed line broadband speed. And we actually did some industry numbers, right? Nokia MBIT report came out and the Ericsson EMR report came out earlier this year. They indicated that 96% of the users in India essentially have used the internet over mobile. So India remains a mobile first country, and the mobile 5G in that sense has really helped to move the KPI. If we look at the Surfshark Digital Quality Index, so this is another global index to essentially look at how a country actually does from a digital economy perspective and the readiness for the digital economy perspective. So in that index, almost the entire improvement which essentially India witnessed in last 1.5 year is contributed due to the mobile broadband internet related part. So clearly, in the EMBB issue that you were asking, I would say that Indian experience has been very well as compared to the rest of the world. You know, people keep talking about the monetization related part, but I think we need to see that. I mean, 2 years ago we were in the spectrum crunch, capacity crunch scenario. India, as a in general telecom systems, today we don't talk about the capacity crunch. We actually have capacity abundance. So I think 5G, if you look at the single most important part has been in the mobile broadband to create this enormous capacity, which has helped the users who are using the 5G phone. This also helps indirectly help the other 4G users because the traffic shift has started to take place, and there are various numbers. So uh, I'll not be able to share the exact number, but it has created enough headroom in the 4G networks so that the people who are having the 4G phones could also essentially utilize on. So I think my take is that there is real good work on the EMBB front which has happened. Now you talked about the other two scenarios because 5G had this MMTC and URLCC. I think to be very honest, there are actually two ways to look at the MMTC related equation. the MMTC held essentially two different technologies, right? For example, NB-IoT is also a MMTC technology, and we are seeing that there is a good traction now in the market on the NB-IoT based devices. There are some large number of orders which are there in the smart meters related piece, and we see that the while it is scaling up, there are certain issues which essentially started to come up. So within TSDSI, we have started some work on improving what can be done from an India specific deployment scenario. But the other scenario of the MMTC was RedCap. RedCap, as you see that since it started come in release 17, so the deployment of RedCap has not happened. We have done trials. We have announced our trials on the RedCap earlier this year with Ericsson. And as the devices will start to come out later this year, I think we'll be ready to essentially roll out the MMTC. I mean, NB-IoT anyway we are doing, and the RedCap based devices also will start to come in and hit the market as well. The third pillar was the URLLCC related scenario. That's something I would say that we are doing experimentations with several companies in the private 5G space, and see that how the URLLC can be deployed. We are also doing some commercial deployments. I mean, if I speak on behalf of Airtel, there are some commercial deployments that we are doing of the private 5G. URLC related requirements are a small segment of this, but we see that this is something which will evolve as we progress, right? And as the more improvements of the 5G advance will come, even the URLLC based scenario will also evolve on that part. So, full tick mark on the EMBB, MMTC, good work has already happened, and URLLC is work in progress in that sense. Thank you.
Thanks, Saurabh. Satish, thanks for joining. I think we can't see your video. Maybe you can switch on the video. So same questions to you, but in addition, I think Jio has also been instrumental in rolling out the fixed wireless access. So what has been your learning with respect to fixed wireless access? Satish, you can hear us?
Yeah, I can hear you.
Yeah, maybe you can switch on the video also.
Sorry, I cannot.
Okay, then it's fine. Yeah, please go ahead. So, yeah.
So what do you want me to comment on fixed wireless?
So the thing is that you have also done the
You
fixed
say some
wireless
good things
access.
about
In
it.
addition, this was the almost like the fourth pillar of usage scenario type thing. So EMBB, MMTC, and URLC, what was the learning from all of these usage scenarios?
Yeah, it's a bit of a tricky question because 5G itself has not been not a very convincing technology as such. So fixed wireless, yeah, there is a demand. That much is clear. But the ideal scenario would have been fixed wireless on millimeter wave. That doesn't happen. Yeah, of course, there are certain 6G, sub 6 gigahertz fixed wireless deployments which are happening. That's more of a replacement for fiber. It's going good, yes, but initially the 5G objective was fixed wireless, at least fixed wireless on millimeter wave. That hasn't happened.
So most of your deployments are in 3.5?
In all of India, there's no millimeter wave deployments, man. So everything is
Okay.
sub 6.
Okay, so how about the other thing? EMBB has been, I think Jio along with Airtel has done the fastest rollout of 5G. Recently, you have also increased the prices, so hopefully people are picking up. So there is a sort of, at least as Saurabh mentioned, there is some success with EMBB. Is it true? And how has been your private network rollouts?
I don't know what is called as some success.
Okay.
Some success. So no comment. Sorry.
Okay. So maybe I should then go to Ravi on this. So I think you have recently just completed the POC trials of 5G. You heard both Saurabh. Saurabh was like sort of happy with at least EMBB. Satish seems to be unhappy with everything. Maybe FWA, at least he sees some market. You have just started the POC, the trials are over. And what was your learning from all the trials which you are doing right now for 5G?
So as you said, we have conducted various pilots and trials on 5G with using various deployment architecture over last years, using both millimeter wave and N78. So I mean, as others are also mentioning that these use cases are very important, and we have been also working with various industries and industry and ecosystem player to test out various use cases which can be beneficial to us or can help us monetize the 5G offerings. So currently, as Saurabh also suggested, I mean, 5G broad MBB, EMBB is the only case, only use case which is really relevant right now, and ha- ha- I mean, it has some perceived value currently, considering the devices and ecosystem available. So this is what we will be starting with, and now since the trial phase is over, and we will be moving on to our commercial phase, commercial rollout phase now. So that is how it is going right now.
Okay, thanks, Ravi. So over to Ashok, sir. So I think DOT has been instrumental in driving the fastest rollout of 5G in India. One of the aspect which is still there, as Saurabh also mentioned, they have covered most of the rural area, but not all of rural area. Specifically from DOT, what exactly needs to be done? Why which needs to be taken care in future as well for the rural areas?
Thank you. So let me also consider what was talked by our earlier speakers, and also your question related to what we are doing at DOT to proliferate 5G and its use cases. Uh, so first of all, I mean, there have been apprehension about 5G, but if you look at the numbers, Saurabh was also telling in respect of our country. So basically, as of perhaps June, so we already have 1.7 billion kind of a 5G connections worldwide, global. So which is quite good if you look at how 4G had gone, the progress of the 4G when it was launched, and how 5G has progressed. So the adoption of 5G has been faster compared to the 4G. That's a fact. The other apprehension which some of our speakers were telling about, I mean, we have launched only EMBB and we have not gone to URLLC or MMTC. The one difference which we should understand, that the overall capacity which a 4G system can generate and overall capacity a 5G system can generate, these are two very different things. In 5G, you can generate more capacity, you can have more users within the same area, and you can also offer more speed. So if you continue using only 4G and not deploy 5G, perhaps you are missing something. You may not be able to meet the requirement of the EMBB, which we are now able to do. As Saurabh was telling, that we have abundance of capacity into the network as of now. That is all because of the capabilities of 5G. The larger channel bandwidth or spectrum we can deploy in one BTS. For example, 4G only 20 megahertz. In 5G, I can go to 100 megahertz in FR1 and 400 in FR2. So it creates a capacity, so you can serve more and more people, and more data speed you can offer, which we are really able to see. In 4G era or 4G connection, I get 20 Mbps, where in 5G I get 200 Mbps. So that's a visible difference after launching the 5G. Saurabh was also telling about our ranking, Ookla gives ranking, and I mean, as per their ranking, we are today 12th in the June month, last month. So our ranking was 12th. Even we are ahead of Finland, Sweden, France, developed countries also, in terms of median data speed. This is all because of the 5G. You're talking about what are the government steps. So as you know that this was for the first time. Please recall that up till now, all our operators used to say that they have less spectrum. So whenever there is a quality of service issue, they will always say that spectrum given to us is less. They need more spectrum. This is for the first time that normally, if you see that how much spectrum 5G will require, right? So for all the usage scenario, so the standard is that on the lower band, less than 1 gigahertz, you can have 10 megahertz FDD band. In mid band, you require 100, and in millimeter wave, you may require 800 to 1000 megahertz. And in fact, those spectrums were actually auctioned by DOT, and operators have actually acquired that much spectrum, and they also have their legacy spectrum which they would be refarming, repurposing over a period of time. So this is for the first time that operators are having enough spectrum to launch a particular generation of mobile technology, that is 5G. For example, if you talk about 4G, so 4G was supposed to deliver, say, a peak data rate of 1 Gbps. That was only possible when you have 100 megahertz of channel bandwidth, whereas operators were having 20 megahertz, 30 megahertz. So we could not have achieved those visions. But in 5G, all operators are having sufficient spectrum. So that's also a credit to department or government that that much spectrum was vacated from all the legacy and those were put to auction. And everybody knows that there has been a lot of reform in terms of how you pay the upfront charges. There are multiple way now operators are opting. They can have EMI, 20 years EMI, they can pay upfront, whatever. I mean, all flexibilities are built into that. One of the important aspect of SU charges was also removed, and because of the SU charge removal and the weightage, so the older spectrum SU charge have also drastically reduced once you have acquired millimeter wave and this mid band. So your weighted SUC charge on overall has also reduced. So your liabilities or onto that is actually reduced. In respect of, what government is doing in respect of 5G. So you might have heard about 100 5G lab. So government DOT is supporting setting up of 100 5G lab in 100 institution, which includes certain number of IIT, triple ITs, NITs, and other universities. So basically, the skill requirement to take care of the skill requirement which industry requires. This was very important. So initially we have funded 100, and 50% of that are now operational. You may also be like, for example, although as Saurav told that we are covering almost entire portion of our country, almost I think 80 to 90% geographically we are covering on a 5G signal. But if you look at number of users, the number of users or customers on 5G today stands only at 10%, maybe 12 crore customers are there on 5G. And good part in India and perhaps across the world also that you don't have any differential tariff as on today for availing 5G services. So whatever recharge you have, whatever plan you have, if you have a 5G phone, so you get a 5G service. So that means when I say 12 crores, only 12 crores of mobile customers are actually owning a 5G handset as on today. So that clearly means that there is a lack of availability of 5G, affordable 5G phone in our country. Otherwise, lot more conversion should happen. So perhaps there is a need to bring low cost devices. So on that front also, you may be aware about government's PLI scheme where we are trying to give certain benefit to local manufacturer. And you may also be aware that now mobile phone manufacturing capacity, which is happening in India, is like it has reversed. Earlier, import quantity used to be higher compared to the export one. Now it has actually reversed, and even we are exporting a lot of 5G, 4G phones to outside the country thanks to the government initiative on that. So that's the thing which government is doing. Now coming to the rural area. So rural area basically the idea is that every village should also get coverage and get some sort of broadband, right? And this is happening in many ways. Some of the work related to that are given to even private operators. They are putting towers and trying to roll out either 4G or 5G services. So we call it 4G saturation project, and major part of it is also given to BSNL, which they are trying to roll out with indigenous 4G upgradable to 5G network. You might have also came across one project which we are calling as 5G intelligent village. So we are trying to do some pilots. So we have identified around 10 villages where we want to roll out of 5G network, and also roll out various use cases on 5G, maybe based on agriculture, drone, health, and showcase that the 5G use cases are possible using the network which we have. Some of you may be aware that there was a workshop by Voice, all the Indian indigenous manufacturer association Voice. So they organized a workshop on this particular, and this particular proposal from DOT is live. So anyone interested can actually participate and come out with the solution. Once we are successful with these 10 villages, perhaps we can scale it up to a large number of villages. So that's a kind of a roadmap which DOT would be having. From DOT side, we are also aware that maybe going forward, when more and more customers are coming onto the 5G network, today only 10%, so that will actually increase. So then whatever you are talking about abundance, there may be a requirement of more spectrum, which operators may require, say, after 2, 3, or 4 years. So we are aware that we require more bandwidth, particularly in the lower side and also mid-band side. So we are very much aligned to that requirement, and as and when it is appropriate, we will actually make available those spectrum also. So I think I took more time. Thank you.
Thank you, Ashok sir. So just to take that point further, so if you see in India and everywhere, the main KPI which is used is basically peak data rate. That's how all the operators have been aligning that. But as you understand, there are 15 KPIs or capabilities which are defined in ITU. Do you think we need to look beyond peak data rate? What are the other things which you would suggest as KPI, especially for EMBB?
Yeah, so you're right. So whenever we say peak data rate in today's world, if you are able to achieve a peak data rate, that becomes capacity of that particular BTS, right? So that much is the ideal capacity which one BTS can have, right? Unless you have more than one BTS, or you try to use more dense network, so you create more capacity into that. For example, in 5G, the ITU defined a peak data rate is 20 Gbps in downlink and 10 Gbps in uplink. And if you really want to achieve that 20 Gbps, I think no one has achieved so far. Only 7, 9, or 8 Gbps of the speed we have realized, but not 20 Gbps, which was envisioned by ITU. So in case you want to realize, actually you have to deploy around 400 to 500 megahertz of the channel bandwidth in a particular BTS or cell, and you have to use, say, 8x8 MIMO at least in the downlink direction, and you have to use 256 QAM order of modulation to achieve that. So there are a lot many things which you require to achieve that particular capacity, and that may not be available across the coverage. So that would only be available near to the base stations. So as you go far from the BTS, your speed will be very low. That's why there is also definition of user experience data rate. So some sort of minimum data rate which you will get across the coverage area. So although standards can define certain peak rates, certain rate, user experience data rate, but the real problem is the deployment. So what kind of population you are trying to cover, what is the usage pattern, and how many base stations you are deploying, how much spectrum you are deploying, what technology you are trying to use, how much MIMO you are using, and you also see the market. Even if you can deploy 8x8 MIMO, and in case devices side, if they are not supporting, it becomes very complex or costly to have that much devices, will also not be a problem. So overall a optimal solution. So it's not only peak data rate, but the overall design of the network has to be so that we are able to cater to need of the population of that particular geography. That's my take on, say, peak data rate or other parameters also the same case.
Thank you, Ashok sir. So, Satish, Jio has been instrumental in driving the interoperability KPI in ITU, and I think there was another thing called composability, which was added as modularity in the ITU vision document M.2160. So, what's your take on it? How do we map that into the different usage scenario?
See, one of the biggest drawbacks of 5G has been that there was no change in the overall network architecture in comparison to 4G. In fact, LTE provided more network flexibility in terms of deployment in comparison to what 5G provided. Just to give you an example of how 4G was better, for example, from a B2B perspective in comparison to 5G, I can say that there was data breakout mechanisms available in LTE, which was not carried forward into 5G. I see that as a big drawback. Now, going to 6G, composability, modularity, and all the stuff. The reason why we want this is whatever air interface one might think of in terms of 6G, it's anybody's guess what is you will definitely not get orders of magnitude spectral efficiency over what is already available in 5G. You might increase massive MIMO NES, but massive MIMO deployment has practical issues as we have seen in 5G. So instead of a 32T, 32R, if you say I'll go to whatever 1000 cross 1000 something massive MIMO, come on, take a guess what that will be. Deployment issues are serious concerns. So given that at least we don't anticipate orders of magnitude spectral efficiency in terms of the air interface, what else are we looking for in 6G in comparison to 5G? It's network modularity, because at least modularity, composability, flexibility, whatever one might call it, but interoperability as well, because that's also key. These are the key things which will drive the next round of business. It will help us get into B2B scenarios, business to business scenarios. Today, if we take a 5G network and go to enterprise, they're not very excited, primarily because they have Wi-Fi 6, and you end up competing with technologies such as Wi-Fi 6, 7, whatever. And it's not a very happy scenario to be in for us. Not just because of the price point, there are a lot of other issues, practical issues. Simple issue being enterprises do not want data to be going out of their premises. These simple things today in 5G cannot be managed. Of course, we do have slicing, and that too much of literature on slicing. Not many people have deployed slicing. Even if you deploy slice, what is that? I mean, it's just some guarantees that I provide so that you have some connectivity guarantees. But then guarantees, it's okay. Guarantees that my data remains in my premises. That is the key ask from the enterprises, which we don't have technologies to provide for today in 5G. So in terms of pure network flexibility, 5G was a letdown in comparison to LTE. And we don't want something similar to happen with respect to 6G. And that's one of the reasons why we are very clear. Network flexibility is the first and foremost priority thing for us. Spectral efficiency gains, I'll get additional speed, all fine, great, okay. But network flexibility isn't there. You are not able to deploy it in the right places. Okay, I mean LTE itself, I'm very happy in terms of that. In terms of the data rates, I mean, what spectral efficiency are we talking about? I'm speaking as a consumer. As a consumer, I don't even have a 5G SIM enabled. I'm happy with LTE when I'm mobile. So 6G gives me some additional GBs, extra, etc., whatever. I mean, I'm not too excited. But strictly, this is very important. This network flexibility going forward is very important. Look at the cellular network architecture. It's 30, 40 years old. It's the same architecture from the 2G days, or even AMPS days. Nothing much has changed. If this monolithic big piece of architecture one really cannot think of B2B deployments. That's something will be very clear. That's the direction in which we want to drive the entire specification towards it. Thank you.
Thanks, Satish. Just on the other thing, the Apple Vision Pro, when it was launched, everyone was thinking the XR may happen on 5G, and it was a big let go when they didn't add 5G into that. So the general discussions which I had with Apple was they find that latency is still higher. So I want opinion of both Ravi and after that Saurabh on what exactly happened with latency and how can we tighten that part so that at least in 6G they have Vision Pro or any XR coming up, and that immersive communication is really useful for the operator to roll it out. So specifically on the latency, if both Ravi and Saurabh can talk about it, that would be useful. Ravi, you're on mute, I think.
Hi. So latency, I mean, in case of 5G, unless the URLs is used, it is not very much different than 4G. So, I mean, we will be experiencing somewhere around 10 to 10 to 20 milliseconds of latency. So, unless we go for URLC, the latency values will not come down. And the URLC, we already heard that the devices are not available.
Yeah, that's true. So Saurabh, same opinion. It is the device problem or the network?
Yeah. So let me take a step back, right, and maybe add to this point and as well as to what Satish was essentially highlighting earlier. Uh, if you look at and wear the consumer hat in general, and you look at and we can look at some statistics as well. Today, if you are trying to do something on the smartphone, and I'll come to the Apple Pro and other things as well. If you are doing something on the smartphone, uh, virtually speaking, the need of having extra speed on the smartphone probably doesn't seem really, any application seems to be requiring that part. I think same is true from the latency perspective as well. The latency, I think, is a function of the technology. Latency is a function of the network design and architecture as well. So the impact of the radio technology probably is going to be lesser as compared to where, for example, the application is hosted and where from that is getting delivered in terms of the edge compute and things like this, right? So, the important point which I'm trying to say is that from a consumer perspective, the increase in data rate or the reduction in the latency from the radio technology probably is irrelevant as far as we see. I think they are probably relevant only in the enterprise or B2B use cases, but not practically speaking from a consumer perspective at the moment. The Now coming specifically to the latency related part, I think the network design and architecture and how far your edge location or far edge location is probably will have a greater degree of impact than the radio technology by itself, right? So I don't think that in my view this is a real problem from that perspective. It's a problem to say that, okay, where the applications essentially are hosted. The other reason, and we see that the devices like Apple Pro or any other XR VR device not using 5G is going to be the fact that the battery consumption part of it, right? The initial release 15 and 16, and this has been one important learning that I would say that as a standard setting organizations, we probably need to take it back, is that especially in release 15 16, the energy consumption of devices continues to be extremely high as compared to, because the focus was in terms of achieving peak data throughput or increasing certain part of the KPIs, which probably may not, which are important, but in that piece, if you are consuming more battery, I think that's something which was not really fully factored in. So as a result of that, many of these devices, when especially you are wearing on your head and things like these, so they become kind of a problem more than anything else. And as a result of that, instead of looking at the long range technologies like 5G, some of these people would look at the short range technologies like Wi-Fi to probably, and maybe even tethered devices and things like these. So in nutshell, I would say that from a consumer perspective, whatever we are able to deliver in terms of the data rate, in terms of the latency, I think that these are fine. these will probably start to make difference. Bigger thing, I mean, they will become very important from a B2B perspective. And I agree with what Satish was saying, that the problems which are unsolved in the 5G for enterprise are something that we really look forward to solving as we evolve, right? Some things have started to happen in 5G advanced, but there is only a few things that we'll be able to achieve. So as the next generation of technologies evolve, I think we would want more flexibility, agility in terms of how networks are designed, and solve the some of the issues which industry probably is really demanding, and we probably want to solve these for them.
Thanks, Saurabh. So now coming to the other aspect, the new usage scenarios which are coming up. So to Ravi, especially the sensing is a new application which is being talked about in a big way. So how do you plan to use sensing, and is there some threshold which you are working with on sensing, which you want from a KPI perspective? Ravi, you are on mute.
Just a second. Sorry. So, I mean, normally sensing and communication, they are normally designed separately and occupy different frequency bands. So, but due to wide deployment of high frequency bands and massive MIMO technologies, communication signals in 6G systems tend to have a both resolution in both time and angular domain. So it makes it possible to have a high accuracy sensing using the communication signals. So this usage, I mean, this scenario facilitates new services like sensing, uh, which can be used for surveillance and navigation, object intruder detection, posture or gesture detection, maybe vehicular on
Yeah.
pedestrian detection. So environment monitoring use cases, fire detection. So those a lot of such use cases can be enabled using the sensing, which is enabled by this 6G.
Thanks, Ravi. So now to Saurabh and Satish. So the other use case was AI. Okay. So earlier, if you remember in the ITU, the discussion was should integrated AI and communication be done. Finally, it was converged into AI and communication. So now the question remains: is AI for network or network for AI? And what's your thought on that, Saurabh and then Satish?
Okay. Yeah. Thanks, Jishnu. Because I think this remains a hot topic, and I would assume that it is not a one versus other. It is probably going to be both. The first is AI for network. I mean, AI for network. We believe that, I mean, we don't need to wait for 6G for that to happen. This has started to take place now itself. I mean, and we are using a lot of AI algorithms essentially to do, I mean, various use cases from energy efficiency to load balancing and things like these. And we see, for example, I mean, India is, and it's an interesting discussion, because if you look at most of the capacity in India comes from TDD, whether it is 4G network. In the 4G, for example, we have 2.3 gigahertz as our main band, and in 5G N78, 3.5 gigahertz is the main band. Both of these are TDD spectrum, and ducting, for example, atmospheric ducting is a big issue over here. And we believe that the one of the interesting use cases, and we've been looking to push all the standardization bodies to actually look at how the AI can really look at the ducting detection mitigation part. Today we have certain modules. These are, I mean, whatever is possible with the existing baseline technologies, we try to find out using the AIML algorithms. I mean, take the feed from the weather department, meteorology function, that what is the prediction of the ducting, and then utilize this to actually map this to our physical cell sites, right? I mean, which could actually create impact, and then change their I mean, frame structures on the fly and things like this. So we are doing some stuff. So I believe that the AI for network is a very important thing to increase the efficiency and the performance of the network. I think this is one way of looking this. The second way of looking this would be that, how in the channel modeling, channel estimation, and things like these, beam forming, can you really use the AI to do much better prediction, and then use those model to give better efficiency eventually onto that part, right? So I think this is something, some work is possible now, some work obviously will be possible as we have 6G, 5G advanced discussions starting to take place. I think the second part, which is the network for AI, I think that's the very interesting thing, and we remain engaged with stakeholders, and of course excited to look at the thoughts from others, because again, we don't need to really wait for the 6G to happen for having network for AI related piece. One of the important things which the 3GPP based technology bring to the table is the underlying trust into the data which is being fed. I think when we look at the AI models and look at how the AI is being used, how can we have an inherent trust in the data models and the data which is essentially being used to create it? I think that's going to be very important. And in the value chain, what can be done around it? I think we see that the network for AI probably will play a very important role, for example, on that part. And the network could be an enabler as a compute fabric for the AI related capability. And this is something which is very interesting thing. And I would say that I want to link back to the earlier point with regard to the B2B related piece. So the sensing and AI ML capability or native AI in this, along with the communication, I think will probably become the pillar of the future B2B use cases as well, right? So I think this is something which we see that a lot of work needs to be done by the entire ecosystem to find out what are going to be those use cases where this AI use cases or the sensing use cases essentially can be utilized. So in that sense, the network for AI, I think, remains very interesting area to explore.
Thanks, Saurabh. Satish, you also have the same point that both are possible. AI for network and network for AI, both are relevant.
So I don't understand the difference. What is this network for AI or AI for network?
Okay.
I simply don't understand it. See, AI is a bunch of algorithms.
Right.
So in any standardization body, nobody standardizes algorithms. That's all left for implementation. So what do you talk of AI? When you talk of AI, typically standardization bodies, especially with respect to standardization bodies, you speak of a platform that enables these algorithms, and not just AI. I mean, you can apply any algorithm. I can just give you an example of this Oran RIC. Oran RIC is supposed to be a platform. Nobody tells you what kind of an application you run or what kind of an algorithm you run once the data is made available. The sorry state of affairs in Oran is that even that platform doesn't pull all the information necessary from the run. It's all piecemeal, one application at a time, only load balancing. See, AI algorithms fundamentally has been around for quite some time, and they were expected to solve certain class of problems, and those problems are typically typically to do with uncertainty. If you have intrinsically uncertain nature of the problem, or you can in simplistic terms nonlinear kind of problems, they are the ones where you apply AI algorithms. Not that you don't have any non-AI learning algorithms, even they are there. You can always have a feedback learning algorithm which is not called as neural net. Even those are available, by the way. Second order Kalman filter, third order Kalman filter, that's what all the banks use today to predict the market. They don't use neural nets. If they use neural nets, one odd day it will crash you. It's a what they call it, black swan event. So the trust on AI is very little, but you do have other set of algorithms which can do the job for you, predictive, etc., etc. It can do prediction based on your previous data. There are these kind of extrapolation algorithms which are available, which are not necessarily neural nets. So what is this? Given this background on AI, a good understanding on AI, tell me what is AI for networks or network for AI? What is that?
Okay, so this I think the issue has been also to quantify the whole thing. So maybe that is one issue. So this is a debate which is ongoing in ITU as well as in other bodies. So maybe this is a bigger topic.
In fact, in ITU was sensible enough. IMT 2030 was sensible enough not to use the word. What is it called as?
Integrated AI and communication. Yeah.
No, it was called as AI native.
Right. Yeah.
That's another term. AI. What is AI native? I don't understand what AI native is. But anyway, at least they were sensible enough to remove the term AI native.
AI native from that.
AI assisted can still be understood. AI, whatever, augmented, assisted is all fine, but AI native, what is AI native in communication systems, man?
So that was done, and I think we are running out of time. So one last question to Ashok sir. So ubiquitous connectivity was one thing which was driven from India, and coverage is one of the KPI. Is there other things which you need to look into as part of that ubiquitous connectivity?
Yeah. So I think during 5G also, TSDSI along with IITs and all, we pushed that particular aspect in terms of 5GI as a technology. So the use case was same, that we wanted to enhance coverage from a particular BTSs, and perhaps that got merged with release 17 of 3GPP. So availability of services or the mobile across the globe or across the country is some sort of thing which we require. So there can be many ways one can achieve. One is like you have a better coverage from same BTSs using certain technologies, like earlier we talked about pi by 2 kind of a modulation for 5GI. The other method is that as Satish ji was talking about open API to integrate all kind of access network into the 5G or 6G. So basically, when we are able to integrate sort of say NTN or satellite onto our mobile itself, that means same mobile if I can use in the area where there was no connectivity. So that means satellite can either work as a backhaul, or can work as a bent pipe, or can work as a kind of a BTS itself, right? So you have a coverage in those areas where today we don't have coverage. So ubiquitous connectivity is that. Similarly, when we travel in sea, you don't have mobile connectivity there. Or if you're traveling in a plane, so nowadays, of course, you get in some of the planes, but overall idea is to have a ubiquitous connectivity and continuity of service when you go from one place to other place. This is true for we human, and this is also true for those IoT kind of devices. For example, in a logistics, if some materials are going fitted with IoT sensors, they go through road, they go through sea, they go through sky. So how those equipment can be all the time connected? So that's the ubiquitous connectivity which would be possible with satellite integration, and also some sort of, if you are able to connect all access together, if they are interoperable, in the sense that maybe so 5G we have non-3GPP access concept. If that can further be evolved and make it better, it will be like the dream of ubiquitous coverage will be near to achievement. Thank you.
Thank you, Ashok sir. Thank you for all the panelists. We have run out of time, so we can't take the Q&A from audience. So there are some 10 questions on the Q&A box. Hopefully, you can respond over email on that chat itself. And sorry for not able to take up that question. So thank you, Saurabh, Ashok sir, Ravi, and Satish for joining the panel. And it was a very interesting panel. We learned quite a bit of things from both on 5G as well as 6G usage scenario. And hopefully, as part of TSDSI, we can start contributing and make those changes and make relevant KPIs, etc., which are really useful for this. As mentioned by Satish, Saurabh, etc., we need quite a bit of flexibility, interoperability, etc., which has to be built right from the start of a technology, because this cannot be an afterthought. And hopefully, we will ensure through TSDSI, otherwise as well, to ensure all this network, whatever 6G comes out, it is very flexible and can be used by the operator the way they want to use that thing. Thank you again. Thank you. Bye.
Thank you.
Thank you.
Thank you, Jashwant. Thank you.
So I'll now hand it over back to Akash.
Thank you, sir, and thank you for the discussion. And we request Dr. Bhavanthan to take over.
Bhavanthan, your volume is slightly low.
Yeah.
Okay. Now it's better.
Akash?
Yes, Dr. Bharat.
No, the Q&A, I think it is preferred that the Q&A is answered in the chat box only, isn't it?
Yes.
Yeah. We move to the panel now.
Yes.
So now we have the second panel on use cases for verticals. Go next. So we have the panelists, Dr. Abhishek, Professor Manivannan, and Professor Muralidharan, and Dr. Christian, and Dr. Santa from Tata Motors. So we will have an introduction of the panelists, very brief introduction. So Dr. Abhishek is a faculty with the Institute of Development Research in Banking Technology, and he works a lot on the 5G and contributes immensely with the TSDSI. And he is also having a funded project on 5G use cases lab, and he works various use cases, rural connectivity projects and so on. Next. We have Dr. Christian, who is part of the Nokia Network Architecture Research and Development team at Munich, Germany. And in the past, Christian has been working in 5G network architecture and standardization. Now he is focusing on technology enablers of 6G and mobile networks. He has received his MSc and PhD from Germany. And he has been working with the Nokia Bell Labs and contributing to the 5G systems. And he has co-authored many publications and patents in mobile networking technology. And we have Professor Manivannan from IIT Madras. Professor Manivannan is the faculty at Department of Applied Mechanics, and he is also a visiting scientist with Massachusetts General Hospital and Harvard Medical School in Boston, and is also a faculty member at CMC, visiting faculty member at CMC Vellore. And prior to joining IIT, Dr. Manivannan was a chief architect at MIT Touch Lab at MIT Cambridge, and he has also established Touch Lab at IIT Madras. And Professor Manivannan holds a PhD and ME from Indian Institute of Science. Next. Our other speaker from who will present on the automotive use case is Prasanta Sarkar, who has about 30 years of experience, and he has built indigenous engine management system for the first Tata Nano car, and he has recently designed and developed a digital twin technology for battery and motor for power electronic components. And he is a TSDSI member and contributes to the 6G ambulance project. And finally, we have R. Muralidharan, Mr. R. Muralidharan. He is a fellow of Indian National Academy of Engineering and a life senior member of IEEE. And he is also a professor of practice at IIT Tirupati and CTO at Tata Advanced Systems, Mumbai, responsible for mission critical defense technologies. He has over 44 years of experience in systems engineering. He has been an IEEE volunteer for 46 years, serving as a chair of IEEE India Council and Bombay section. And he has served as vice chair of the Wireless Innovation Forum and board member. His recent research on AI-enabled design agent for software engineering was presented at SERV 21. Yeah, with this background, we will start with the 6G vertical presentation. I would request all the panelists to turn on their camera, and then probably we'll start with the initial presenter, Dr. Christian, to set the context on 6G. And then going forward, we would like to see a vertical specific presentation from on defense, fintech, and automotive and health. Initially, I would request Dr. Christian to set the context Akash, you have the presentation from Dr. Christian, or?
I think I can share myself.
Okay, yeah, that will be nice.
Yeah, and okay, let me see. So first of all, can you hear me well?
Yeah, we can hear you.
Okay. Okay, just a second. Here we go. So thanks a lot, Pavendan, for this nice introduction. It's my pleasure today to speak to you in this very interesting panel. I'm really looking forward to the session. Can you briefly confirm that you see my screen?
Yeah, we can see. Maybe you can go on a full screen. Yeah, we can
Here we
see.
go.
Thank you.
Okay, very good. So yeah, welcome. Greetings from Munich. My name is Christian, based in Munich, Germany, from Nokia. It's my great pleasure to speak to you today. Thanks a lot for this invitation, and thanks already for this very interesting first panel. It was very interesting to listen to the different insights there. So on this panel, it's now my pleasure to give a brief introduction on the perspective of usage scenarios, in particular looking at the verticals. So this is, of course, a very specific perspective looking beyond the CSPs, and is already something where 5G was promising many things. And if you look at this brief slide here, you can also see that basically we had 3G basic communication services being deployed, mobile services. 4G was the first mobile standard really going into broadband connectivity, true mobile internet access, and then 5G was actually trying and targeting to unleash also the potential of machines and sensors, tapping into this vertical domain as the first standard. As we have heard already on the first panel, there are different views on how much 5G has delivered on that promise. But certainly, I think we can all agree that there is some way to go still until we can fully unleash the potential of mobile communication systems towards the vertical industries, both those that are present in today's panel, but also those beyond. So I will have a more detailed slide on that. But let's take a step back before we look into usage scenarios, and let's recap or briefly think about what we actually want to achieve, because we have talked a lot about technologies and technology enablers during the design of 5G. And maybe we were also running a bit short in looking into truly into aspects that truly unleash the value creation or the monetization part. There's a lot of discussions these days on what are the real value add features, both in 5G and then also even more so in the upcoming 6G domain. So where's the potential to create value from deployed networks, and where's the potential to monetize new features and potentially new infrastructure and newly deployed services. So if you look at the entire ecosystem that we see, we can of course see that there is an extension of classical fields. So we know the industry domain, formerly known as Industry 4.0, now what some people tend to call Industry 5.0, with new capabilities in digital twinning, but also more data-centric network services, and then enabling also new application services. Sorry for this. Which of course tries to tap into the AI. Just a second. Which tries to tap into the data-driven network analytics. We've heard on this before, but of course there's a lot of potential there that we haven't fully understood yet. So certainly 6G will be built around this as an additional value. Exposure of network capabilities as such, which is called API economy in this slide here. So more profoundly enabling the developer ecosystem with truly value-add services and underlying APIs that the network can provide. That's another source for additional value creation. And then in particular, also, if you look at the cloud continuum, another dimension is something where total cost of ownership, TCO, plays a big role, of course. So this is clearly something that we must address in 6G, where that we truly leverage the cloud to bring down total cost of ownership of networks also. So it's balancing additional value creation with bringing down costs, both in terms of rollout, but then also in terms of operational costs. And there a lot is about, of course, simplification when we talk about operating our networks. And this at the same time will, of course, also help to bring down, to emphasize or to achieve the sustainability KPIs. Energy efficiency certainly being the most important one among those. So reducing total cost of ownership, and then also a particular metric, of course, overall energy consumption, both in RAN, core transport networks, but also more on the classical IT infrastructure side, so running data centers. This will have a tremendous impact on the sustainability KPI. All right, looking into the concrete use cases. So Nokia is leading a flagship project in the European Union, which is called Hexa-X2. Many of you probably know it from one context or the other, looking at use cases and then the technology enablers, and then also system architecture and radio level solutions for 6G. And it has done an intensive analysis also in the use case scenario, which also reflects, I dare to say, not only the European view, but also the view of many other regions. So I wanted to provide that perspective, and later in the panel we can then pick the most interesting usage scenarios, use cases also from the India ecosystem, of course, from this perspective. Overall, the project has 44 partners, so it very well represents not only the mobile industry domain, but also the verticals. So there are several verticals involved. You see Sony is involved. We have a couple of companies from also from more, let's say, a media-driven context, but also Siemens, you see. There is a broad representation of different verticals there. Briefly, catching up on this value aspect. So beyond the traditional performance indicators that the project looks at, and which are very well known from earlier generations, which are about performance of the network, but also performance of radio in particular, the project has made an effort to, in particular, look at those so-called key value indicators, which are trying to capture and to quantify also new indicators that try to look at these really value creation metrics in different dimensions. So sustainability is, of course, one thing, but then also we have these aspects of security and trustworthiness, but also economic and social sustainability. So how 6G networks can help to provide sustainable economic growth, also how they can support environmental sustainability improvements, that of course relates to such things as biodiversity, our natural resources, be it water, minerals, whatever, to use those more efficiently. And then last but not least, of course, also the social sustainability in sense of how healthy are our societies, right? So this is one part, is inclusion, of course, but also how 6G networks can help us to become better societies along a diverse set of dimensions, from mental health to how we interact as human beings, but also how we, for example, try to incorporate it in daily life, or to make accessible in daily life digital services to different stakeholders, from the very young generation up to the elderly, in different contexts of their life. And then, of course, new capability areas. This is, for example, looking into areas like joint communication and sensing services. Also, this convergence of computing and networking services to have a more holistic view. So these are the aspects the project and we as the project lead look into. Now, this opens up a whole box of a whole landscape, I shall say, of use cases. Let me focus on the most interesting ones for our panel. I've tried to put them a little bit in bold font. Let me start here on the lower right. So clearly, health services is something that we have on the radar, both in the project, but also as Nokia building the networks. Remote services is something that health services that has been discussed in the past, telehealth, but also new services that help to provide analytical services on different kinds of medical data is something that we want to enable, and that the network can enrich with specific services, complementing, of course, the application domain analytics. Similarly, we can say that in the financial sector, there are the requirements of real time, which is, of course, overlapping with reality gaming, MR, XR, VR gaming, but these true real time expectations of basically a haptic interaction and real-time interaction between humans in remote locations, but also between machines and humans, or machines and machines, is a clear requirement that different use cases have, and that 6G networks need to address in a more profound way even than 5G networks. Looking at, for example, then this will also be touched in our panel then in the upcoming discussion and the presentations from my fellow panel colleagues. Vehicular services, of course, V2X, especially the cellular V2X, of course, will continue to play an important role. Again, AI-assisted solutions to increase the level of autonomy, autonomous driving. This plays an important role, but of course also increased requirements from governments, for example, on the security and safety aspects of such autonomous driving solutions will put a high or will be a challenging requirement to be met by the network connectivity, by the underlying network connectivity, but of course also by the services we run on top. Further, defense is a big topic. So 6G for defense and military networks, putting specific requirements, for example, in terms of robustness, in terms of availability of network services, but also, of course, simply performance requirements, which can be quite demanding. So also here, this is an increasingly relevant segment to be addressed due to geopolitical developments, of course, but also in general, the defense sector is a big market and a big player in the whole mobile ecosystem that we, as from the vendor side, but also from those organizations that run the networks, need to address. Beyond those specific use cases, of course, you can see the clustering here. Robots will be a big topic also when we talk about addressing elderlies in nursery homes. Sustainability use cases, and also twinning, of course, is important use case. So this is maybe some food for thought for the panel discussion. I want to close at this stage, also leaving some time, of course, for my fellow panel colleagues. Thank you for now, and looking forward to our discussion.
Thank you. Thank you very much, Dr. Christian, for setting the context and giving a brief on the Hexa project, 6G project, and various 6G use cases, giving us the overview of the 6G use cases. And now I would like to invite Mr. R. Muralidharan, CTO from Tata Advanced Systems, to give us a defense perspective and 6G impact on military use cases and so forth.
Yeah. So, thank you, Mr. Pavandan. Thank you very much for your kind words. Thank you, Mr. Madan. Thank you, TSDSI, for giving me an opportunity. And thank you, Christian, for setting the context. Yeah. So first, let me start with a disclaimer. Talking about defense, I clarify that I'm not sharing any secret. All I'm sharing is what is there in the public domain, which I have analyzed and sharing with you. Nothing secret. Okay. So you can quote me and do it very clearly, and I'm also clear on my consciousness. Okay. Yeah. So looking at the global military communication market, just to give an idea, Christian said that's a huge market. Yes, it is $35 billion a year. In 2023, the global military communication market was $35 billion and is growing at a rate, CAGR of 7 to 8%. So it's important that the military communication market is growing very fast. Okay, and the military communication includes major SATCOM, wired and wireless communication, heavily HF communication, and a good amount of data communication, data links. Right now, what was the challenge in the military communication has been there were numerous standards in the military communication. All the things started in military. Now, of course, the technology is originally the technology used to come from military to civil. Now it's going the other way around. It's taking from civil to the military. Example is 5G and 6G. So the presence of numerous standards, various radios, even in one army, one group of army cannot talk to another group of army because there are different standards, different OEMs, different radios. Okay, this is a major challenge. Forget about army talking to Navy or Navy talking to Air Force. Within the army itself, the infantry cannot talk to the artillery, artillery cannot talk to somebody else, things like that, right? So in 1997, there was an effort to standardize or rather bring in standards for communication. The famous JTRS program was initiated, and the concept of a software-defined radio was brought in. We said that we'll have a difference in the platform and the waveform. The waveform can be portable and it can be put into any radio, any standard platform, and you can achieve interoperability. Okay, so the basic challenge was interoperability. Otherwise, the earlier defense personnel had to carry 3-4 radios to talk to various networks. Okay, so they wanted a one radio with multiple waveforms, switch waveforms on the fly, change the modality of the radio, and be interoperable. So this, to a certain extent, has been successful. And this was the JTRS program, which the US Army started. Then we went on to the SOR program in the Europe. Now these have been very well established and going good. Now, looking back, what is happening in the battlefield? In a battle scenario, what has happened there? Today, the battlefield is totally net-centric. All weapon systems are interconnected, heavy connectivity, digitally controlled, right? So, which means they have to be wireless communication between every subsystem. A radar has to talk to a command post has to talk to a gun system, and the gun has to fire, or a weapon system has to be activated, right? So this is called as the OODA loop. The latency here has to be minimum. Otherwise, once you detect a target, you have to fire quickly. So there are many decision points in between. So in a net-centric connected battlefield, communication is a big challenge. It's a big necessity. Okay, there the importance is about latency, bandwidth, or rather the data rate, right? Main things. So a connected battlefield needs a very robust and reliable communication network. Otherwise, each weapon system will be blind and it will not be able to act. Okay, we call it the OODA loop. The OODA loop should be the minimum or better than the enemies, so that you can be more, your action will be faster than the enemy's action. Okay. Now, the challenges are secure communication. Can the enemy eavesdrop you and find out what you're doing? So there should be secure communication in the battlefield. And the other important thing is you should not be jammed. If you're jammed and you cannot communicate, then you are totally blind in the battlefield and you cannot do anything. So anti-jamming techniques and secure communication are the most important for a net-centric battlefield. Now you look at the 6G and 5G developments, which the military is keenly watching, and they are trying to adopt that. What is the biggest advantage a 6G, 5G network brings into the military environment is a unifying technology. One technology across all services. So interoperability becomes an ease. And it comes with a high data rate. And as we talk about the ultra reliable, low latency communication, right? And again, the biggest challenge is in a battlefield, I cannot afford to spend a lot of energy in communication, right? So it should be energy efficient. One of the speakers did mention about that. There's a big challenge in 5G. We hope this will be resolved in the 6G, right? And in the 6G and 5G, the standalone or private networks is what is interesting to the military, because there will be networks of their own, which can be well designed. I did hear that the network flexibility, architecture is still age old, but those things can be resolved in a military environment. We can design our own private networks, use the same standards, depend on the standards for the interoperability and the other reliability issues and the latency issues, and develop your own network. So it needs a lot of development of the network itself. Okay, but it will be mostly standalone networks with the gateways to the civil networks for other communication. Recently, Hughes Network in the US deployed a private 5G network in the Naval Air Station in Washington State, and they have been very happy with the transformative communication that it could bring in. Right? Military has spent a lot of money, world over. Military has spent a lot of money in developing solutions. One of the biggest example is the WIN-T in the US. You can look up the Google WIN-T. Was it a big success, or was it a big failure, or was it a non-starter? A lot of challenges happened. And in India also, an Indian Army has a project called Sambhav. It's a 5G based solution with multiple tiers of encryption. So the secure aspect of it. Okay, and the US is just embarking on a new development called the JADC2, Joint All Domain Command and Control Network, which is a totally wireless network, where they are thinking of using 5G, 6G technologies for the interoperability and ease of communication, and less about the communication aspects and focus more on the security aspects of it. And with this, let me pause here. There is a lot of opportunity, not only for the communication aspects, but new network developments, security, and energy efficiency. Okay. With this, thank you.
Thank you, sir. I think there's a lot of opportunity of 6G in defense. We can hear from you, and various examples you have given. So we will now move to the next speaker, Dr. Abhishek Thakur from IDRBT, to give us a perspective on fintech and the 6G impact on fintech. Welcome, Dr. Abhishek.
Thank you, sir. And thanks to both Christian and sir for setting the context. In fact, Army, as he was discussing, looks to be equally spread out as the banking sector that I represent. Again, a disclaimer from my side, it is we are part of the regulators. So none of what I'm speaking about is from the regulator's perspective. It's our own 5G lab experiences we are sharing. So quickly looking at how we see 5G and beyond, including 6G, shaping up the financial ecosystem. We are having one corner, which is the enterprise experience, the other, which is the retail or consumer experience. Cybersecurity is the #1 pillar on both sides. For enterprise experience, we are also looking at access in terms of reach, inclusion, and affordability. All said and done, the cost of doing business, and especially India being a very value conscious market, affordability and inclusion are strong needs for us. Inclusion is also on the rural scenarios. Also, where we see 5G and related ecosystem as they evolve is the governance, risk and compliance part in enterprise. Today, all the banks and regulated entities are spending a lot of effort, and a holistic inclusion of governance, risk and compliance in the next generation core technologies can provide a tremendous value addition for the ecosystem. There are also endpoints. In sense of time, I'm not going into it. Some of it was also discussed in the previous session. The last point I wanted to focus on the enterprise scenario was the spread of the financial systems, the banks and the network is so massive that especially in India, we are looking at if a bank decides to move to a 5G plus scenario, then really need to have multi-telco options available to them, which is missing today. How do we get into that scenario for banks to actually seriously consider this in their enterprise play is a gap that we have to figure out how to fill. On the retail side, phygital is one aspect where we have made a lot of success in sense of delivering services to the rural areas. Pure digital, the trust in rural areas is not as good. They still prefer brick and mortar banks. And as a backup, the Bank Mitra or Bank Sakhi scenarios where a representative, not an employee of bank, is bringing digital services on a shared device in an affordable manner. This ecosystem has grown a lot in the last 10 years. How can we strengthen it to be more sustainable and reducing wastage and other things is something that we have to continue to build upon. The next point, which is the digital public infrastructure slice. Now, DPI is something we are talking for the last 2 years, but if you look at it, Aadhaar to UPI and other things, we have been on it for more than 10 years now. Now, when we are looking at a DPI ecosystem and with the current networks, availability and resilience is very important. A Kisan Andolan or a strike or exam being conducted, the networks get shut off, affecting the DPI services. The last point, this is where again we have to look at how platforms like Sahmati or consent management can be used to benefit the end customers across sectors. Mitigating fraud is the starting point. Can we have better OTP or authentication mechanisms? Beyond consent, can we start thinking more from not just KYC, but also protect our customers? Again, this needs a transdisciplinary thought process. The last point is on grievance and dispute resolution. If an OTP has been delivered, for example, can we look at how to audit or get the logs of the OTP delivery and the IMEI binding? Today, a bank says OTP was delivered. Customer does not know whether it was on their device or SIM swapping or something has happened. So again, more data flows with privacy preservation is what I wanted to touch on. I will stop here. Thank you.
Sorry. Thank you, Dr. Abhishek, for giving us the perspective on the fintech. And now let us move to Mr. Prashant Datta from Tata Motors. He will give us the view on 6G impact on automotive vertical. Over to you, Prashanta. You are able to hear us?
Yeah. Good afternoon, all. So the thing here we'll talk about the 6G applications on automotive. So as there are numerous applications. One already Christian told about the autonomous driving and the ADAS systems. The other applications, particularly for India, is that ambulance, particularly 6G enabled ambulance. And then the other things are again related to the first is the patient care and second is the accident avoidance. So that is a vehicle to X. So vehicle to vehicle, vehicle to infrastructure, vehicle to passenger, etc. So these two use cases we'll discuss for 2-3 minutes. The next slide, please. So, like in the case of 6G, it should be a continuation or above what we have seen during the launch of 5G. During the 5G, they launched a AMBU pods where the few of the group companies, so they made the ambulance equipped with 5G enabled technologies. Even I think the Prime Minister also visited that this ambulance and appreciated. So here the same way 6G will be having more features, and particularly in the where there may be no surgeon or surgeon not available, that type of thing, or maybe 6G. In case of 6G, maybe we can think for like robots also. So that maybe that we like here in 5G. In case of 5G, there is no robot. I can say robot doctor, but here we can say that maybe with a robot doctor or something we can push it. Maybe the next slide, please. So next slide is here V2X. It is also very much applicable for Indian context. The way if you see that when there is a cross section and two vehicles are coming in 90 degrees, there is always clash or accident happens. And here some person who cannot see will be able to, because of some vehicle or some obstructions are there. So from the vehicular side, he will get warning. Same way cyclist is moving on road, will get warning. So then the vehicle to home or where the vehicle is, then the vehicle to vehicle signal post is again very important for India. Suppose there is no people in the morning, we have seen that still signal is on and off based on the timer. If we have this features, we'll be getting green signals more often. Then charging station. So if the vehicle is of electric vehicle, you can get more information about the charger and charging. So these are the few use cases where the 6G will be playing a great role, and we'd like to, well, we have to develop applications based on that. So all over the world, people are already done. We will also look for to build this. Okay, thank you. That's all from my side.
Thank you very much, Dr. Prashanta. So we'll now move to Professor Manivannan to give us a perspective on 6G on health vertical.
Thank you, Dr. Bhavendran.
Sir, over to you, Professor
Thank
Manivannan.
you all the panelists who talked before me. I think the health aspect has been touched in some aspect or other by the previous panelists. I just wanted to now highlight again the important use cases of the healthcare with 6G in 4 different technology verticals. Okay, so of course the 6G as a technology is going to influence AI, ML, omics, and AR, VR, and internet. All these 4 verticals which I'm going to discuss the healthcare. Now 6G will have a lot of impact, but particularly each of these verticals, let me go through some of the use cases one by one. So if you take AI, ML, the predictive analysis and continuous monitoring is going to be now possible in the coming days. So we have this huge data coming from the continuous monitoring, and therefore now predictive analysis on the fly, and with a massive data, with a massive connectivity coming from the several devices, right? That is going to be possible, and in real time medical image and signal processing and understanding, that is going to be possible in the coming days with now 5G. That's again very important because the doctors, they want and this the understanding of AI based help in understanding the images or diagnosis, and that would be possible in real time. Of course, now natural language processing, NLM and LLM, now all these things is improving a lot now. So more and more real time will help the doctors and particularly healthcare in many different aspects. For example, the training that is going to be useful. Now, real-time understanding and the translation, and then therefore the collaboration from a distance, and so telemedicine, all those things, this NLM and LLM is going to be very, very useful. And then robotic process automation. There are a lot of automation that can be possible in the hospital, and therefore AIML is going to be very useful with a 6G. And emergency response, real-time data sharing, and the drones and autonomous vehicle navigating, bringing the resources in a very short time, and then putting the data together and then analyzing and then making a decision and in a critical time, that is going to be possible. So that is as far as the AIML is concerned. And as omics is concerned, we have this genomics, proteomics, and transcriptomics, and there are a lot of other omics are coming. The focus is on all this omics is the more and more precision medicine and personalized medicine. So towards this personalized and precision medicine, we need to get a lot more data, do the number crunching over the lot more data, and then make decisions in real time. So that is where this real-time genomics analytics is going to be possible. And this omics data from multiple omics data has to be integrated, put together, and then the analytics has to be done. That is a challenge, and that may be possible in the coming days. And then, of course, remote monitoring, remote diagnosis, telemedicine we are talking about. So again, telemedicine and with the limited data is what now possible. With the 5G and 6G data, we'll have much more data, and therefore the doctors would be able to accurately personalize the therapy as well as the diagnosis in the future. Particularly, not only visual and auditory data, but also the haptic data. The doctors from a remote side, they would be able to touch and feel it. So touch and palpate it, for example. Diagnosis is now possible because now the tactile internet is there. Now sub millisecond latency is therefore possible. Therefore, now they can find out the through the palpation much more details about the diseases remotely, right? And of course, drug discovery, the simulation over the number crunching and accelerated research with now a lot many drugs, putting them together simulations is possible, and clinical trial data can be combined together, compiled together, and then the drug discovery time can be reduced in a very, very short time in the future. And so that's about the omics. The next slide, we talk about how AR, VR, and MR and haptics can be useful as far as the healthcare is concerned. Next slide, please. In the AR, VR, again, training, medical training and education is going to be revolutionized. So immersive training is becoming possible now. Now 360-degree videos is now possible that can be streamed in real time and with a 6G, and it can be interactive as well. So far now 360 images or videos are not interactive. In the future, probably 6G will enable the 360-degree videos interactive, and therefore the medical training education is much more realistic. Now virtual consultations, the real patient can consult a virtual doctor, or the virtual patient can consult the real doctor. That is much possible sitting at home and with the probably the touch feedback as well. Right? So rehabilitation, not just the training, we are talking about the rehabilitation as well. Now AR, VR, and MRN with the haptics, the rehabilitation is going to be transformed, and probably the transformed rehabilitation would be much better than the traditional rehabilitations in the 6G era. So for example, we have done experimented with stroke rehabilitation. We found that the AR, VR, and the haptics based rehabilitation is much better than the traditional rehabilitation, and the mental rehabilitation is going to be much better with the AR, VR, and the haptics. That's again a lot of disabilities are being rehabilitated now. There are a lot of applications coming up, but with the 6G addition of haptics, that is going to really speed up the rehabilitation. And then surgical pre-planning. So with the 6G, the doctors will be able to practice before the surgery on the real data of the patient. It's not on some other data, on the real data of the real patient, and they will be able to do the pre-planning and then go to the real surgery. And then intraoperative assistance with the AR glasses, and the doctors, the surgeons can get the real-time assistance, and with the AI supported some analytics, that all can happen now. Telemedicine with the haptics, of course. Now I mentioned about the palpation, which is a very, very crude but very important diagnostic tool for all the doctors. And finally, the final vertical in terms of the internet, how healthcare and the 6G can be use cases can evolve, is about the metaverse is coming up. Metaverse is nothing but the 3D internet, where it is not only social network is there, but also the people, citizens from our Indian villages will be able to go to hospital, high-end hospital in the city in the metaverse. So that is again possible. So they will not feel the left out because of this maybe internet and 6G era internet. Health data management, huge amount of data can be managed, and m-health applications, mobile health applications. So many different healthcare applications, apps are there, but unfortunately, they have poor resolution, poor accuracy and precision. With a 6G, with a huge amount of data processing capabilities, they can improve the accuracy and the precision. Therefore, there will be more and more m-health applications, I would say. Emergency response and disaster management, again, with a huge amount of data and the network of devices, we can respond to the emergencies a much better way. And of course, remote assistance as well. Again, the power of high data rate and ultra low latency, we would be able to offer remote assistance in the case of the emergency response. So in all these things, the human-centric approach is going to be more and more in the coming days. So although AI, ML, and internet and IoT, omics, I'm talking about it, the human is going to be the center. The well-being is going to be the center. Mental well-being is going to be more and more important. Therefore, anything to do with the improving the mental well-being or the healthcare, it would be encouraged. And 6G has a big role to play, an important role to play. I wanted to end with one particular caution, and a lot of panelists talk about the digital twin. Digital twin, as far as the healthcare is concerned, it is little ironic, in the sense that digital twin, in our understanding, in our definition, is a two-way interaction. I have the digital model of the real thing. When I change in the digital model, the real also changes. When I change in the real, the digital copy changes as well. But in a real healthcare system, digital twin of a human being is little ironical. I cannot change the human physiology by changing the digital model. That's why we have to be a little cautious in not calling digital twin patient digital twin. So I would stop here. I'll be happy to now hand over the session to other panelists. Thank you.
Thank you very much for your take on the 6G use case in the healthcare vertical. I would urge the audience questions to be posted on the Q&A, so that based on the time availability, we would like to go around the panelists to ask those questions. I request the audience to post any questions you may have to the panelists on the Q&A chat box. So now, from what Professor Manivannan has presented, I would just to start from there. I think Professor Manivannan, being an expert in haptic and tactile and applying technology on, especially as a domain expert, he's trying to look at the application in health, especially the upcoming emerging technology domains. So the previous panel mentioned the penetration of 5G mostly in broadband use cases, less on the URLLC and MMTC kind of use cases. Considering what Professor Manivannan highlighted in terms of the real-time communication and the haptic requirement and tactile kind of use cases, so what is the kind of uptake or the pilot that is being carried out in Europe? I would like to go to Dr. Christian to see from the European experience and hear from you in terms of how are the other use cases, especially the URLLC and its adoption in Europe, and what kind of pilots are being carried out in Europe, and what is your take, considering that you also listened to the previous panel, and what do you see based on also Professor Manivannan's from the domain point of view in health? There is a lot of use cases in health and other like defense, the real-time communication based on URLLC. There is a real requirement, but we are not seeing the use cases in the real life. So what is your take? And yeah, please share us your experience.
Yeah, thanks a lot, Pavanathan. A very interesting question. In particular, looking at the healthcare sector, I would extend it a little bit towards also the say nursing and how basically how to attract or how to deal actually with the elderly population, which is a very specific phenomenon in Western societies, and also, for example, in Japan. This is of course slightly different in India. That's understood. So in Western countries, including Germany, but also others, there is a lot of proof of concepts and prototypical deployments in the 5G advanced space to basically support taking care of elderly, including then that, I mean, there is no strict border, right, between nursing in the narrower sense and then medical care. So in this area, we see many activities. This includes, of course, robots also that need to be controlled and need to have their application logic, including AIML support. LLM is the keyword here, generative AI, that needs to be processed either locally or for complex processing on a remote node, on an edge node. So that's where networks come into play. The question is if this similar logic can be applied to India, of course. So I think indeed there that the actual medical market, so healthcare has bigger opportunities compared to nursing of elderly people. So that would be my take on it. So I wouldn't, from my point of view, the experience in Europe is not fully applicable to India, probably, as far as I understand.
Yeah. Thank you. Thank you very much. So let me just go to the fintech use case which Dr. Abhishek presented on. So Dr. Abhishek, you were also working on the rural connectivity aspect. How do you see that the distributed transactions, because the transaction volumes are going to be very high going forward, from the toll payments to mobile banking, UPI transactions. So is there a role of 6G or will 6G provide some advantage going forward, considering the volume of transactions?
Yeah, we do expect a lot to happen in 5G advanced satellite and 6G scenarios, because all said and done, still a significant portion of our population is not covered by network. I'm just talking about Indian perspective, be it Andaman, be it the hilly areas or the semi-forest and forest areas. So the satellite part has a big role to play. The other part, and that is where I was trying to allude when I was presenting, was how do we improve the trust? All said and done, rural population is not digitally savvy. They typically rely on somebody else to do it for them. Not everybody would have a 6G device once 6G launches for the first few years. Affordability, economic impact, all those things are significantly there. Now, as we are designing the core and trying to bring in these solutions, we have to be empathetic to this aspect.
Thank you, Dr. Abhishek. So I would like to bring in Mr. R. Muralidharan on the defense use case. Sir, you mentioned about a really connected battlefield. That was quite interesting. So we have definitely space, air, ground, everything to be integrated going forward in 6G, because satellite communication all will be integrated in 6G, I suppose, going even though things are early now. So how do you see the military use case when multiple such the use cases are to be integrated, and also the devices in the battlefield are to be talking to each other, as you highlighted? So how do you see this space and air ground operations are going to be coordinated with 6G features?
Thank you. It's a good question. And this is the interesting point of 6G. So 6G has a concept called SAGIN, Space, Air, Ground Integrated Network. So the standards and the mechanisms are going to be in place in 6G for the SAGIN network, so which can be easily adopted by the military. The only addition the military has to do in that is bring in the right encryption standards and anti-jamming technologies into that. By adopting these two normal standards into the 6G SAGIN standards, we should be a space command should be able to talk to a Navy team and the Army team and share situation awareness. See, the problem with the military is fratricide. You kill your own brother. You don't know who your enemy is, who your brother is. So if we can disseminate situation awareness all over the battlefield, including air, ground, and the sea, there will be less fratricide, less killing of your own brothers, right? So the SAGIN network of concept of 6G is going to be very helpful, so that the military doesn't have to put a lot of research and a lot of other things into the development of these networks. The number of people researching in military is very less, especially on the fundamental physics and communication aspects. So this can be borrowed from the civil world and add the security into it. Security meaning encryption and probably anti-jamming techniques, etc., into that, and then you can have a seamless communication with space command, air command, ground command, and the sea commands. All of them can be together. This is the big dream of the military, that yes, we can seamlessly communicate through all these things. Of course, today, the SATCOM is heavily used in the military. The largest use case, the largest application is satellite communication, because you are in remote areas, you don't have base stations, you have nothing. So you need a satellite communication to do that. And satellite communication is easy to jam and spoof, but there are techniques to overcome that, right? So this 6G is being seen as a big boom, okay, in the military world, all over the military, all the militaries world over, especially because of this seamless integration happening. And all you do is take the standard thing, change a few things here and there, create a private network, okay, with a gateway to operate to a civil network and make it secure as well as jam-proof. Yeah, thank you.
Thank you, sir. So just, I think we have just one last question. I would like to go to Professor Manivannan on the 360-degree video scenes that will get created going forward in immersive interactive experience that you have highlighted, sir. So, so how 6G technology can be used in those kind of use cases where I understand that they will involve really high bandwidth with stringent QoS requirements and so forth. So how do you see this this applications can benefit out of 6G?
So very interesting question. Thank you. So this 360-degree videos, the bandwidth is requirement is very, very high, and particularly we also, if it has to be interactive, then and the latency requirement is very, very low. So therefore now 5G or 6G, and it needs to be they are the right platform. So without the interaction, if it has to be just explode, then it can be buffered like what now we are doing with YouTubes and other players, right? But if it has to be interactive, then and there's latency and jittery and other things have to be really taken care. Right now, that the 360-degree technology is like black and white, like when we had the images in the black and white, like so the resolution is very, very poor. The feature when we want HD quality at the 360-degree level, the requirement is really, really very high. As of now, probably now let me give an idea about maybe giga pixels, gigabytes per second or per frame. That is that is the kind of things we need. And the latency is now probably about 30 milliseconds. Interactive means it has to be 1 millisecond. As of now, it is not possible to realize it. Maybe in the 10 years down the line, may be possible. Thank you.
Thank you, sir. Thank you very much to all the panelists for a wonderful discussion in terms of how 6G will impact various use cases and verticals. And really, I thank all the panelists for taking time. And Dr. Christian from connecting from all the way from Germany and presenting the European use cases. Thanks to all the panelists, and I thank TSDSI for giving us the opportunity to present in this wonderful panel. And I would like to close the session. The Q&A will be answered over email, and the TSDSI team will coordinate for Secretariat will coordinate for over email, and these will be answered in the shortly. Thank you very much. And if there is anything more to you,
on the behalf of TSDSI, expert chairs, distinguished speakers, and the audience, we had at times 200 plus audience for this session, maybe 225 or so. It was a very enriching session, and we thank all the panelists, chairs, and the audience for being with us today. Thank you.
Thank you, sir. Thank you, everyone.
Thank you.
Thank you.
Bye-bye.
Thank you all. Bye.